Hi, welcome to 2.3a. Today we're talking about ions. And if you've been doing your readings, you've already seen these. So first let's review the notations. First you have periodic table notation, in which you're given the atomic number, the symbol, the name, and the average atomic mass. Your other two notations are complete notation, where it is read the symbol, the atomic mass, the atomic number, and the charge in the order of A, B, C, D. And then you have hyphen notation that is just the symbol and the atomic mass. So an ion is an element that has gained or lost one or more electrons. It has a charge. If it has a positive charge, a positive ion is called a cation, and a negative ion is called an anion. Ions, right? These charges are also called oxidations. And we're going to add them to your periodic table now. So be sure you grab your periodic table. Oxidation numbers should be written above your valence numbers. And so they are, a valence of 1 has an oxidation of 1 positive, 2 is 2 positive, 3 is 3 positive, 4 is plus or minus 4. A valence of 5 is 3 negative, 6 is 2 negative, 7 is 1 negative, and 8 is 0. The transition metals have oxidations that have to be given specifically for each problem, but they will always be positive. And we'll talk more about the oxidation of the transitions later. The oxidation, like the valence, shows the number of electrons that an element would like to gain, being negative, or lose, being positive, to become complete or stable. The oxidation number will be used when bonding elements together, which is what we'll do in Unit 3. So at the top of your periodic table, it should be listed as 1 circled, and 1 positive. So be sure you have all three, the group, the valence, and the oxidation, on your periodic table. Ion identification. If an element is given to you in the form of the periodic table, it is not ever going to be an ion, because the periodic table is electrically neutral because the electron number equals the proton number. Thank you, song. But if you're given a problem that is written in complete notation and it has a charge, a D location, it is automatically an ion. So here's an example. Here's what you have to be able to do. Looking at Be 9, 4, 2 positive, you have to be able to identify this as beryllium. There are 4 protons, 5 neutrons, and now 2 electrons. In order to find the number of electrons, you take the atomic number minus the charge. To find the number of electrons, you take the atomic number minus the charge. This is still in group 2, period 2, and it is an alkaline earth metal. The dot diagram would be Be with 2 dots. The electron configuration would simply be 1s2 now, because it only has 2 electrons, and the electron configuration is based on the number of electrons. The Bohr condensed would read 4 protons and 5 neutrons in the nucleus, and shell 1 would have 2 electrons on it. This is an ion. Second example, you're given F19, 1 negative. This is fluorine. It has 9 protons, 10 neutrons, and now 10 electrons. It is still in group 17, period 2, and it is a reactive nonmetal gas. Its dot diagram would be F with 7 dots, because the dot diagram is still based on the periodic table, not on the number of electrons that it has. The electron configuration is based on the number of electrons, so it would now read 1s2, 2s2, 2p6. The Bohr condensed would be 9 protons and 10 neutrons in the nucleus. Shell 1 would have 2, and shell 2 would have 8. This is an ion. We're going to do lots in class. Thanks for watching.